I'm Swati Verma, Assistant Professor, Chhattisgarh Swami Vivekanand Technical University, CSVTU Bhilai. I welcome you all to the course of Industrial Automation and Drive. Today, we will begin with our 8th lecture focusing on two fundamental concepts in industrial automation. First, automation hierarchy. Second, the basic component of automation system. Let's start with the automation hierarchy. Automation hierarchy refers to the structural levels at which various automation components operate within an industrial system. It's like the organizational chart of an automated system defining how each level interacts and contributes to the overall operation of the system. Mainly, the hierarchy system consists of four main levels. First, the field level, the control level, supervisory level, and the enterprise level. First, the field level. This is the lowest level where sensors and actuators basically operate. They interact directly with the physical processes. The second, control level, involves the controllers like PLCs, programmable logic controllers that manage the field devices. They execute the control algorithms to regulate the processes. Third is the supervisory level. At this level, the systems like SCADA, the supervisory control and data acquisition, and HMI, human machine interface, provides the monitoring and supervisory control. They gather data from the control level and provide interfaces for human operators. Fourth and last is the enterprise level. This top level integrates the automation system with business and the manufacturing execution systems like ERP and MES. It focuses mainly on the enterprise-wide data management and the decision making. As Sir Rahul Baghel already mentioned in its first lecture that the key components of industrial automation are control devices, sensors, actuators, specialized software, robotics and network communication, which comes under the different automation hierarchy levels. In these lectures, we are going to discuss field level in details, where we will cover sensors and actuators in today's class. The control level and supervised level we will cover in the upcoming lectures of our course. So let's start with the field level. This is where the physical processes meet the automation system. First, we will see the role of sensors in the automation system. First is detection and monitoring. Sensors are critical for real-time detection and monitoring of various physical states within an industrial process. This includes detecting the temperature changes, measuring the pressure change, tracking the displacement and monitoring force or load conditions. Second is the output signal production. When exposed to these physical phenomena, the sensors generate output signals that the automation system can interpret and respond to, which ensures the precise control over the manufacturing process. Third, there are many types and terminologies which are used in the sensor process. Generally, a device which senses a physical quantity and converts it into an electrical signal falls under this category. The term sensor can be used interchangeably with the transducer and meter through slight distinctions exist. First, the transducers. Specifically, this device converts the physical quantities into electrical signals. When dealing with analog outputs, the transducers mainly provide a continuous signal that varies in proportion to the measured parameter. Next are the switches. Switches are binary or digital sensors that produce a discrete output signal which is mainly on and off. They are basically used to indicate whether a certain conditions like a threshold temperature or pressure has been met or not. Next is the digital transducers. These are transducers which are equipped with analog to digital converters known as ADC that produce the digital signal suitable for direct integration with the digital controllers. Now the output signal types. The first output signal type is the analog output. This analog outputs provide a continuous signal which are often in the form of a current which ranges in 4 to 20 milliampere or a voltage ranges from 0 to 10 volt which is proportional to the measured variable. For instance, a temperature sensors might output a range of signals corresponding to a different temperature levels. For example, if a temperature sensor is outputting 4 to 20 milliampere DC current for pressure variations from 0 to 725 psi and allows for digital detailed monitoring and control. Next is the digital and discrete output. These outputs are mainly binary and indicate the presence or absence of any condition. The output is typically an on and off signal, which is simple used for making yes or no decision in automation system. Example, a proximity sensor outputs an on signal when an object is detected within a certain range and off when it is outside that prescribed range. Thermal overload relays are essential devices which are used to protect electrical motors from overcurrent conditions that could cause damage. These relays are not traditional switches or relays, instead, they function as sensors detecting the excessive motor current. When integrated with power relays, they form a unified device within the motor's power circuit. This integration allows the thermal overload relay to indirectly stop the motor by interrupting the control circuit of the power relay when an overcurrent condition is detected. At the heart of the thermal overload relay operation is the bimetallic strip, a component which is made of two metals with different thermal expansion properties. As the motor current increases, the strip heats up and bends, and if the motor current exceeds its nominal value for an extended range of period, the bending strip triggers a mechanism that deactivates the power relay, thereby stopping the motor to prevent further damage of the system. The relay typically features the double pole single throw DPST contacts that switch states in response to the bimetallic strip's bending. This contact can either stop the motor or provide an indication of an overload condition. The strip can be directly heated by the motor's current or can be indirectly through an insulated winding. Through normal operation, the strip remains straight, but when the relays contact, they maintain their default positions. However, when the motor current rises above the safe threshold value, the strip bends and will activate a trip lever which changes the state of the contact to halt and to stop the motor. After cooling, the strip returns to its original position, which can be reset manually or automatically. The relays often include a manual test button to verify their functionality within the control circuit. In three-phase system generally, the thermal overload relays typically include three bimetal strips, each monitoring one phase. This design allows the relay to detect not only overcurrent but also phase the imbalance or the losses. These relays cover a range of motor currents and can be adjusted to match the specific requirements of different motors. For large size motors, particularly those with currents exceeding the 80 ampere of current, the thermal overload relays work with current transformers where the relay detects the secondary current from the transformer. This setup mainly ensures the accurate protection for the high current applications. The normally open, the NO contact of the relay can also be used to signal an overload condition, providing a clear identification of a fault. Overall, the thermal overload relays are critical for maintaining the safe and efficient operation of the electrical motors by preventing the damage from the prolonged overcurrent conditions. They combine the sophisticated sensing with robust protection mechanism, ensuring motors are safeguarded against potential overloads. Now, let's talk about the proximity switches. The proximity switches are vital sensors or switches which are basically used in industrial automation for the non-contact detection of objects within their sensing range. The switches mainly operate without any physical contact and which makes them suitable for other applications where the durability and the precision are very crucial for process. There are mainly three primarily types of proximity switches which based on their operating principles. These are first inductive, second is capacitive and third is magnetic proximity switches. Let's start with the first inductive proximity switches. This inductive proximity switch mainly detects the metallic objects through the variations in the magnetic inductance. When a metallic object enters the electromagnetic field, which is mainly generated by the switch, it induces an eddy current that alters the field and triggers the sensor output. They are widely used due to their robustness and reliability in detecting the metal objects. Next comes the capacitive proximity switches. These capacitive proximity switches, unlike the inductive switches, can detect both metallic as well as non-metallic objects by sensing the changes in capacitance caused by the objects entering their electrostatic field. This mainly makes them versatile for detecting a variety of materials, which includes the paper, glass, and also the liquids. Next comes the third, magnetic proximity switches. This magnetic proximity switches mainly utilize the variations in magnetic flow to detect the presence of ferrous materials. They are often used in applications where detecting the magnetic fields of ferrous materials is required, such as gear rotation monitoring. The advantages of using the proximity switches include their long electrical life, resistance to vibrations and harsh environments, capability to operate under both AC and DC voltage, and last, their effectiveness in high speed and high frequency applications. Additionally, they have no moving parts, which enhances their durability and reduces the maintenance needs and cost too. The main parameters for selecting this proximity switches include detection distance, object placement distance, power supply, response time, operating frequency. First, detection distance is defined as the maximum range within the switch can sense any object. Second, object placement distance is the distance which is calculated between the object and the switch sensing area, which is generally less than the detection distance for the effective operation of that switch. Third main key parameter to select is the power supply, which signifies the voltage range within which any switch operates. The fourth key parameter is the response time. It is the time which is defined taken by the switch to react to the presence of any object or any variable. Next is the operating frequency. The maximum rate at which the switch can toggle between on and off state or switch can transit between the on and off states is defined as the operating frequency. Mainly the proximity switches are available in various forms such as cylindrical shape, rectangular shape, and are also available in the slot types, and each of these type are suited to different application needs. Internally, this typically include components like an LC oscillator, a Smith trigger unit, and also an amplifier switching circuit. Mainly next comes the inductive switches, which creates a high frequency electromagnetic field in the presence of a metallic object, which reduces the oscillation amplitude of the field and triggers the switch and makes the trigger to switch on. Next are the capacitive switches, which mainly generates an electrostatic field and changes the capacitance which is caused due to nearby objects and triggers their operation. The magnetic switches mainly work by detecting the changes in the magnetic flow caused by the movement of ferrous materials through the magnetic field. These all types of sensors or switches are often connected to power supplies and loads, either using a two wire configuration or either using a three wire configuration. The presence of residual current in two wire setups can be considered when connecting to a sensitive electronic circuits. Next is the proximity switches application. Mainly they are extensively used in the industrial settings for applications such as position detection, object counting, and mainly the machine monitoring. They're also used critically in the robotics application for detecting the proximity or closeness to any object, and also in the safety system to monitor the access points. Now let's talk about the limit switches. Now the limit switches are the mechanical devices with electrical contacts that detect the and or limit of any motion. They operate through the rectilinear motion and force of a plunger, which activates the internal contact. The plunger movement returns to its original position with a return spring. Limit switches are housed in aluminum or a plastic for its protection, insulation, safety. They are typically actuated mechanically by moving the objects like piston rods or through a shaft. To ensure the compatibility with various motion directions, an actuator head is adapted to the limit switch body. This limit switch body design allows for the detection of different moving objects. These limit switches are widely available with various actuators heads and of sizes from sub miniature to heavy duty, and also in different rotary arm styles, operating forces and environmental tolerances. The switches are more affordable than proximity or the photoelectric switches and are suitable for applications where non-contact actuation is unnecessary. They have electrical ratings around 250 volt AC and 10 to 15 ampere current range. Some limit switches feature LED or also the neon lamp status indicators. When actuated, the limit switches provide an electrical signal and that triggers a control system response and can ignite the LED or the neon lamp. Next, the level switches or the level sensors. These devices are mainly used to detect the height of any liquid or granular materials in tanks or silos. They come in different types from fully electronic to purely mechanical. The main purpose of using these level switches or level sensors is to determine if a liquid or a material has reached a specific level in the system. The electronic level switches for conductive liquids mainly use electrodes to sense if the level is between the two predefined points or between a two predefined range. They are commonly used in industries handling the conductive liquids like water, juices, and milk. The capacitive level switches mainly detect the presence of liquid or the bulk solids by measuring the capacitance changes. These are suitable for non-conductive liquids and various solid materials too. Next comes the electronic level sensors, which emits the ultrasonic waves and measures the time it takes for the reflection to determine the level. Okay, they are useful for detecting the liquids, sludge, and solids, providing either digital or analog outputs. The radar type level sensors uses radar signals to give the precise measurement even under challenging conditions. Next, the float level switches. These float level switches are simple devices where a floating magnet or a metallic ball opens or closes a contact based on the liquid level. They are very cost effective and are most widely used in many applications. The optical level switches work by detecting the refraction of infrared light through a liquid, making them ideal for small devices and the transparent liquids such as used in the vending machines and also in the medical equipments. Next is a flow switch. In many industrial settings, it is important to detect if a liquid is flowing through a pipe or not. For example, if a machine cooling system needs to monitor water flow to avoid the overheating of a system and to prevent the damage if the pump fails due to overheating. Now, these flow switches can be detect or can sense when the flow rate is above a certain level and can alert when it drops below that certain point. The pedal type flow switches is one of the type of flow switch which are mechanical in nature and uses an electric contact. They have a pedal inside the pipe that moves when the liquid flows and which triggers a switch and to toggle it to on and off condition. When the flow stops, the pedal returns to its original position, and but the switches can be installed on both horizontal and vertical pipes and can have different pedal size or can have different pipe size. Next is the thermal dispersion flow switch type. It uses the heat to detect the flow. They have two temperature sensors, one measures the fluid temperature and other is heated temperature. The difference in temperature between the two sensors changes with the rate of flow. For example, if the higher flow rate cools the heat sensor more, which reduces the temperature difference, while lower flow rate do less cooling and increases the temperature difference between them. This change in the temperature difference is converted into a switch signal and can be identified or can be seen through a LED or through a neon lamp. The thermal dispersion switches are precise and are very fast, and since it consists no moving parts, it is more durable and is more sensitive and suitable for detecting the low flow rates too. Next, the temperature and the pressure switch. Generally in the industrial process, monitoring and controlling the temperature is a very common task for automation engineers. Heat can be a positive factor, like when it is heated to melt the plastic for molding, it is considered as a positive. But if it is caused by any friction in a machinery part, it is considered as a negative factor. So regardless of the cause, it is crucial to continuously monitor the temperature in the system and take the action if it exceeds a set or a desired limit. The temperature detection can be simple, like an on off switch or a toggle switch, and can be more precise with the temperature sensing, measuring the temperature as a variable. Now, the temperature sensors can be divided into contact and non contact types. The contact sensor touches the object to measure its temperature, while the non contact sensor detects the temperature by measuring the heat radiation. There are mainly two types of temperature sensors, including bimetal temperature switches. These are mechanical sensors with a strip made of two metals that bends when heated and which opens the electric contact to signal the high temperatures. Next is the thermocouples. These sensors use two different metals joining at one end. The temperature difference between the joined and unjoined ends create a small voltage that can be measured and used for the switching purpose. Next is the resistance temperature detectors, commonly known as the RTDs. These sensors measure the temperature by detecting the changes in the electrical resistance. Made from the metals like platinum, generally the resistance temperature detectors provide accurate readings over a wide temperature range. Next is thermistor. Similar to the resistance temperature detectors, this sensors resistance changes significantly with temperature. They are made from ceramic materials and are sensitive to the small temperature changes too. Next are the infrared sensors. This non-contact sensor detect the thermal radiation emitted by objects, which makes them useful for measuring the temperature from a long distance too. Next are the semiconductor sensors. These semiconductor sensors are integrated circuits that measures the temperature based on the properties of transistors. Next are the pressure sensors, which are commonly used in the industrial process. The pressure sensors measure the pressure of fluid and gases and can provide either an analog signal or a digital switching signal as an output. They often use a diaphragm or a piston mechanism to convert the pressure into any movement, which is can be measured later. Some pressure switches can detect the difference between the two pressures, mainly called as the differential pressure switches, and can have the adjustable set points for activating the switch. While there are many other types of pressure sensors which are used to measure various physical quantities, but the basic principle remains the same. The sensors provide data to a process controller to help and maintain optimal conditions in an automated systems. Next comes the actuators. The actuator is a device that converts the energy into a mechanical force which are needed to create motion or perform any specific actions. In industrial production lines, actuators are critical because they enable the automation and meaningful production processes. Without actuators, a production line would consist only of the passive components and automation system would be unable to perform their intended functions. I mean, actuator can be called as the active component of any automation system. There are many types of actuators categorized by their operational principles. But here are some of the actuators, the commonly used actuators which are listed below, like the thermal actuators, electric actuators, pneumatic actuators, hydraulic actuators, and last is the micro electromechanical systems which is called as MEMS. Now the thermal actuators. The thermal actuators convert the thermal energy into a movement. An example is the bimetallic strip actuator, which is basically made from two metals with different expansion rates, which bands when heated and is used generally in the thermal overload relays. Next is the electric actuators. It includes different kind of motors such as stepper motors, servo motors and linear motors which converts the electrical energy into a mechanical or a kinetic energy. The high power electric motors are often considered separately from a low power actuators in the industrial context. Next are the AC and DC motors which are basically operate based on the electromagnetic induction principles where interaction between the rotor and the stator magnetic field generates torque. The electric motors have specific operational characteristics. The DC motors require polarity reversal to change the direction, while AC motors, particularly induction motors, are preferred in the automation industry for their efficiency and the low maintenance. Next, the stepper motors move in precise, discrete steps controlled by the electric pulses, making them ideal for the open loop control applications. The servo motors used in closed loop control systems mainly include a motor, feedback device, and controller for precise motion control. Mainly, these motors are easily interfaced with programmable logic controllers, allowing for the accurate speed, accurate position, and accurate direction control. Next comes the pneumatic actuators. The pneumatic actuators use the pressurized air to create mechanical motion typically through the piston cylinder assembly. They are suitable for moving light objects and tasks which require less precise motion control, such as pushing objects on conveyor belt or transporting the components in an automated production lines. The pneumatic actuators are easy to implement and also requires a simple control logic, making them ideal for the various manufacturing tasks. Next comes the hydraulic actuators. The hydraulic actuators operated using pressurized fuel, usually oil, to create the mechanical motion. Since fluids are incompressible, the hydraulic systems are used in applications which require high force and precise control. The hydraulic actuator's operation is similar to the pneumatic actuators, but mainly it differs in terms of its construction and application due to the nature of the working fluid. Next comes the micro electromechanical system, commonly known as MEMS. This MEMS utilizes microfabrication technology to create the miniaturized actuators that converts the signal or energy into mechanical effect at a small scale. This micro electromechanical systems actuators include electrostatic, piezoelectric, magnetic, and as well as thermal mechanism. These tiny actuators are used in various industries for applications such as microvalves for gas and the liquid control, microgrippers for robotic surgery, and the focusing mechanism for camera lenses which are used in the mobile devices nowadays. So today that's all for this lecture. In this lecture we have covered the automation hierarchy, the basic components of automation systems, and learned in detail about the sensors and actuators which are the main systems used in the automation system. In the next lecture we will explore more about the PLC, the programmable logic controllers, and the fundamentals behind the PLC, the programmable logic controls. That's all about this lecture. Thank you.